Dear students, welcome to our class on why the sky looks blue. Here you see the first video. Here uh, you are seeing the sky blue, the ground part which is looking in different color. Now here I would like to enlighten you on one important point. It is that the visible part of the spectrum has V, I, B, Z, Y, O, R. Okay. So in this V, I, B, Z, Y, O, R, the blue and violet, okay, B and V, part of the light reaches our eyes from all directions on a clear day because these are scattered more. You see, in this particular video, you will find now, you will find more contrasting. Blue, exactly blue. Other colors slightly violet from the airplane, Why it is so? It is because we cannot see the violet very well. Why we cannot see the violet very well is the violet part is more scattered and absorbed at the top of the atmosphere. So here the sky is blue due to a phenomenon called Rayleigh scattering, RELAIGH, RELAIGH, Rayleigh scattering. This scattering refers to a scattering of electromagnetic radiation of which light is a form, okay, by particles of a much smaller wavelength. Now, here I would like to explain to you. See here. Now, exactly what we saw in the earlier photographed here, the difference is at a lower elevation. At a lower elevation, okay, you are finding a violet color more. Here, now, in this, you will find the clouds background, the clouds, and then behind the blue sky. Here, I would like to once again impress upon you that the relay scattering, RELEIGH, relay scattering refers to the scattering of electromagnetic radiation by particles of a much smaller wavelength. Electromagnetic radiation means light is a part of it. Now, most important thing is these shorter wavelengths corresponds to which shorter wavelengths in the VIB blue. Violet, okay, as I said earlier, it is absorbed by top of the atmosphere and we cannot see it. These shorter wavelengths correspond to blue hues. Hence, when we look at the sky, we see it as blue. Here you see another angle, from another angle with cloud, okay, front of it and then sky behind it. You see here, It's more and more. Here, what I am interested in impress upon you is that here the violet is totally absorbed as compared to 1 minute before what you have seen. Now, next you see here. Now, here you see. Yes, I am giving more importance here to the blue sky behind the cloud. This cloud is a yellow cloud. What are the three low clouds? Stratocumulus, stratus, and nimbostratus. This is the stratocumulus cloud expanding to stratocumulus, almost stratus cloud becoming a stratocumulus cloud. This is the phenomenon that I observed. As here now, here you see uh, another. Yeah, further clear here is sky from high, with clear cut stratocumulus, that is low cloud, background and surface. Background and surface. Here, now I would like to impress upon you why Why does sky look blue on a clear day? Now this is a very clear day. In this video, this is a very clear day. Why does the sky look blue here? A clear cloudless daytime sky is blue. A clear cloudless daytime sky is blue because molecules in the air scatter blue light from the sun more than they scatter the last one red color. Again, I repeat it. Molecules in the air. Now you see the video. Molecules in the air scatter more and more blue light from the sun. Okay, then they scatter the red color. That's why on a clear day, this is a clear day here, you see, on a clear day, okay, the sky is much blue in color than a cloudy day, When we look towards the sun at sunrise and sunset, we see red and orange colors. This I had explained to you earlier. Here we are seeing only the blue and blue color. Now, here you see, more of the sky path I have exposed here. Molecules in the air scatter blue light from the sun more than they scatter the red color. That's why on a clear day, the sky looks blue in color. When we look towards the sun at sunset, we see the red and orange colors because the blue light has more scattered out. It has more scattered out and away from the line of our sight. So that is very interesting to discuss with you. Now, here, another scientific phenomenon I would like to share with you is that as white light passes through our atmosphere, tiny air molecules cause scatter. The scattering caused by these tiny air molecules, known as relay scattering, increases as the wavelength decreases. I repeat the statement. The scattering caused by tiny air molecules increases as the wavelength decreases. Therefore, blue light is scattered more than red color and the sky appears blue during the daytime. Relay scattering occurs when the scattering particles is smaller than wavelength of radiation. This scattering is as much forward as backward. This is as much forward as backward. This is a very interesting thing. Atmosphere gases cause this scattering. Atmospheric gases. What are the gases in atmosphere? Nitrogen, oxygen, carbon dioxide, whatnot, krypton, xenon, all these things, So they are responsible for this particular scattering. That's what we call it as the relay scattering. Relay scattering is the reason. Now you see both the ground and the sky here in this video. Okay. So this is what I would like to share with you.